What happens when you run this command? kubectl apply, and you provide a deployment file. This beautiful Nginx deployment. Can you answer this question? You can say, for example, it creates a deployment and a pods. It is correct, but we want to dive deeper. So try to answer it yourself, pause the video and try to answer. Okay, I hope you did so. So let's move on to the next part. Let's see actually the whole picture. Let's see the whole picture. The whole picture is Kubernetes architecture. Let's talk about Kubernetes architecture a little bit to understand the flow. Let's explore each component of a Kubernetes. When we talk about Kubernetes, we implicitly mean a cluster. We implicitly mean a cluster. And as you can see on this diagram, we have two nodes. Node 1, it is called master node, and a set of master nodes called control plane. So this is brain of the system. It is a brain. And the second node is worker node. The worker node just runs pods. Just runs pods. Each of the node has a set of components. Let's talk about it. So the control plane consists of API server. Let's zoom in a little bit. So this is control plane. And control plane consists of API server. API server is just REST API server that you talk to when you're using kubectl. You also have a database where you store the state of a cluster. Not you, but the API server. When you apply something, this is stored in this etcd database. You have scheduler. When you create a pod, this pod has to be assigned somewhere, to some node. And you have controller manager. So controller manager is just binary, big blob of binaries that consists of just different controllers. For example, you can have deployment controller, you can have replica set controller, you can have service controller, because Kubernetes cluster consists just of control loops, basically. So the worker node, second part is a worker node. Worker node has three main components. It is called kubelet, kubeproxy, and CRI. CRI is just a fancy way saying container runtime interface. It is just interface, and it has implementations. For example, the popular one is called containerd. Containerd used a lot. And let's talk about each one. Kubelet. Kubelet is just an agent that runs on your node, and when scheduler assigns pod to this node where this kubelet agent is running, kubelet creates the actual container. Kubelet talks to this CRI stuff, for example, containerd. It talks to containerd. It asks containerd to create a container. It runs init containers, startup probes, liveness probes, etc. and reports back to the API server the state that container is running. And you have this kubectl component. So kubectl component responsible for networking, just responsible for forwarding, setting up networking, so the traffic can be forwarded to your container that is running on this node. All right. Let's zoom out. And let's go back to our main question. What really happens when you run this command? Let's go to the flow. As I said, when you're using kubectl command, you're actually talking to the API server of the cluster. You're talking to a control plane, right? So to talk to an API server, you have to have a credentials. It is called kubeconfig, right? You have a kubeconfig, so we can talk to an API server. So your kubectl client reads your kubeconfig, reads your payload, your deployment YAML file, and it sends a request to an API server saying, hey, server, create this deployment. The server runs a set of checks. First of all, it checks that you're authorized. It checks authentication. It runs a chain of admission webhooks. It runs validation. And if everything is okay, if it is fine, then it writes or updates in a database the state or creates a new state, creates new deployment. API server creates new deployment, and then we move to the next step. The next step is controllers. I talked about controller manager. So you have in a cluster a set of controllers. For example, when we are talking about deployment, we created a deployment. API server created this deployment in a database. The state of the cluster has changed, and deployment controller sees that something changed. It gets an event that new deployment has been created. So this deployment controller creates replica set. It creates a replica set. And when deployment controller creates a replica set controller kicks in, and replica set controller creates pods. So these controllers watching resources in a cluster, and they're talking to API server, actually. They get notified that they create resources, and they report back the state to the API server, to the brain of the system. And when new pod is created, it just created in a database. Nothing is running like a real pod, like a real container. It's just in a pending state because it is just a record. This pod is just a record in the etcd database. So the scheduler sees that new pod created in a database, new resource created in the database. Scheduler decides that this pod should be assigned to some node, right? So it should decide to which node assign this pod. It runs some calculations, some algorithms, and decide to assign pod to a node, right? When the scheduler assigns pod to a node, kubelet, the agent running on the node, it sees that new pod assigned to this node. So the kubelet talks to container runtime interface. It talks to container runtime interface and creates a container, actual running container. And then kubeproxy taps networking and stuff like that. So the container can get the traffic, right? An IP address, a traffic, and so on. So this is it. I hope you learned something new. Hope this was useful for you. And bye. See you in the next one.